Hi, I'm Pat Hindle with Microwave Journal. I'm here at IMS2022 talking with Abhishek Kapoor, Vice President of Sales at Anokiwave. So Anokiwave has been very focused on the 5G and satellite market. What trends are you seeing there these days?
We are finally seeing that 5G, there is this prominence of phased array active antennas, and as you can see, the market has fully recognized that phased array active antennas are needed for millimeter wave 5G, and a lot of companies are coming up with IC solutions. Anokiwave was one of the first companies to come up with that. And on the 5G market, with active antennas being the baseline, now we are seeing the market also pick up. We are seeing the volumes on IC as well as the base stations go up. We think that in 2023 we will see a very significant increase in the volumes, and given the current semiconductor supply chain, the orders are starting now, and 2024 is the real ramp-up year. And on the SATCOM side, as you are all following, probably keeping on track, the big players like the SpaceX's of the world, OneWebs, they are launching many satellites, they are deploying, they are providing service, and there are more constellations to be launched. So there is a growing need for user terminals, enterprise terminals, and other classes of SATCOM terminals based on phased array active antennas that's coming up. And the growth is not just limited to North America at this time. It's going into Europe now, and it's also coming up in Asia Pacific. So we are seeing all across the board growth in millimeter wave 5G, millimeter wave SATCOM based on phased array active antennas in Ku and Ka band.
And so Anokiwave is on their fourth generation,
Yes.
I think, for 5G products. Been doing it a long time and optimized the process, I think, a lot.
Yes.
Can you tell us about some of the products that you're showing here at IMS 2022?
Sure. So as you mentioned, we just announced the release of our generation 4th of 5G beamformer ICs and introduced a new product category that we call IF transceivers. So we come up with a new generation of products about every 12 to 18 months, and the goal is to push the limits of performance, improve performance, reduce cost, reduce the DC power so the radios can be made smaller and more energy efficient. And that's exactly what we did in the fourth generation of beamformer ICs. There are three main points in the beamformers. We made them multi-band, so one IC is covering multiple different 5G bands in one, so that way you need fewer SKUs of radio to provide a solution for different 5G bands. Additionally, and most importantly, we increase the linear output power and reduce the DC power, so that means you need fewer ICs per radio, more energy efficient. And the third, and most importantly, we reduce the cost. So now you need fewer ICs and you have lower cost per IC. So that significantly brings down the overall cost of the radio, building a millimeter wave active antenna. There are a whole bunch of other digital features like having DPD enabled capability in there, and many other functions in terms of temperature and other telemetries. The second thing that we have introduced in the fourth generation is our IF transceivers, which is a highly integrated product which combines two up and down converters, one PLL VCO, including the loop filters and other ancillary components, and a driver amp, all into one IC. So it's basically 4 or 5 RF functions that you would typically buy discretely in one IC itself. And that's a very unique way of integration that really simplifies the overall signal chain. So essentially, if you have to think, you just need two types of ICs, one beamformer IC and one of this IF transceiver to complete your entire millimeter wave antenna front end all the way down to IF. The goal is to do smart integration, not just high integration. And this integration at the IF level really simplifies the overall design for the customer. And to augment all of this, what we have done is we have actually built arrays that customers can buy and evaluate performance using our fourth generation ICs. This is our latest array that uses our fourth generation beamformer ICs as well as the IF transceiver. And the idea is that a customer who is wanting to start doing a new design, they can take this evaluation innovator kit and evaluate the overall array level performance before they even begin the design, so they can have confidence in what our ICs can do. The idea is to truly look at the data and not just rely on whatever is written on the data sheet specs. So as we say, don't trust what we say, don't trust what anyone else says, trust the data, trust the measurements, and that's what we are providing to the customers.
And your ICs have enabled some really neat high-level integration of these arrays. Can you show us some of those?
Yes, absolutely. So just as an example, there are two arrays over here. So one array is based on our Gen 3 ICs over here, and this array is based on Gen 4 ICs. Now it's two different configurations in terms of EIRP level, so that's why the number of beamformers over here is different. But the point I want to highlight is what a smart integration does. So in a typical beamformer IC, in a typical configuration, we would have two up and down converters, one for each polarization, and you would have a driver ramp to drive the whole array, and you have a PLL VCO that's a separate unit that you would buy discretely from somewhere else. Now you could take 1, 2, 3, and 4th component and put that into a single IC, as you can see right over here, with this high level of integration that we are offering. And on the beamformer IC side, you can greatly reduce the number of ICs that you need because of the high linear output power and the low DC power that you get. So we believe that what we are offering today in the market is the highest level of linear output power and lowest DC power, making it the highest linear power efficiency solution.
Well, great. Thanks for talking with me today, Abhishek. We are talking here from IMS 2022 in Denver.